Okay, welcome back. We're now going to do the final questions on this worksheet. It's question number 4. So having a look at question 4, there are 2 here. I'm not doing a full solution. I'm just going to help you along to get the equations that you need, and you can do the mathematics hopefully yourself. If there's any problems, you can email me and I can help you out through that last part. So having a look here, we need to just do a force analysis of this diagram here to find T1 and T2, so T1 and T2 there. On this one over here, it's a very similar diagram to what you're used to. Here you're finding T2 and the mass of this one here. All right, let's start with question 4a. With 4a, let's get rid of question 3. Once again, we always start with a force diagram, and drawing the forces diagram on this one, we have a 40 kilogram mass going down there. So that one there is 40 kilograms, and that's the mg force. We have a tensional force going up this direction, and we'll call that's actually T2. And we know that this angle here is 60. We mightn't use that angle. We might try and find a better angle in a tick. And this one over here, let's make it a bit of a bend so it doesn't look like a straight line. And that one there is T1. And we know that this angle there is 70. Okay, I'm not going to pop that 70 in there yet. Right, so the mg is in the cardinal direction, directly down. So these two here have to be resolved. To resolve it, I'm just going to do T1 first. Doing T1, I would go this way and then that way. Now, we were told that this angle over here is 70. That means that this angle in here is 20. It's probably easier. I don't know. I haven't done this question yet. I'm doing it with you now. I'm thinking of using that one over there because that would be T1 cos 20, and this is T1 sine 20. I don't know if it makes it any easier or not. It's just I'm keeping the angle close to the center. Resolving this one now. You've been doing this a while, so you don't need me to walk you through it. Now, I don't know. This one over here is 30. This one's 60. Which one do we choose? I'm just going to keep it away so my diagram's a little bit clearer. So that's T2 cos 60, and this one here will be T2 sine 60. Okay. Once again, all of these are in static equilibrium. So that means that the vertical forces are in balance. So this is a vertical upward force. This is a downward force, and that is a downward force. So looking at which forces are equal, that means that this force here, the T2 sine 60, must equal the 2 downward forces. So T2 sine 60 would equal T1 sine 20 plus mg. Now, mg, as we know, because m is 40, that's 40 times 9.8, which equals, let's do that, that's 392. 392 newtons there. So I'm just going to cross that up there. Actually, I might just make it cleaner and oops, you can't even see what I'm doing up there. That's 392. Okay, so just to recap, because that probably was off the screen when I wasn't seeing it, this vertical force here, T2 sine 60, equals the sum of the 2 downward forces. And all I've done is get rid of mg, which was in this position over here, and replace it with 392. Now, looking at the horizontal forces, we know that this force and that force are the only 2 horizontal forces, and they are they're basically acting against each other to make them balance out. So T2 cos 60 must equal T1 cos 20. Okay. Now, if you use the 30 degree over here, you would have different values. It doesn't matter where you put these angles. You'd have a cos instead of a sine, but you'd have the sine of or the cos of the complementary angle. Okay, our job is to find, make sure that's T1 there, it's T1 cos 20. We need to find T1 and T2. So we're going to have to solve simultaneously, as we always do, and you choose either T1 or T2. Using the second equation here, I'm going to get rid of, let's get rid of T, well, I don't care. So they make it T2 because it's on that side, and that's T1 on cos 20 over cos 60. Just be very mindful, cos 20 and cos 60 are two values. They do not cancel causes, just remind you of that. Right, so that means I'm going to now go up to equation number 1. Now equation number 1, I'm going to bring this onto this side over here. So that was, or is, T2 sine 60 minus T1 sine 20 equals 392. Now I'm going to get rid of T2, so that becomes T1 cos 20 over cos 60 times sine 60 minus T1 sine 20 equals 392. So all I've done is substitute this into here. At this point here, take out T1. So T1 is cos 20 on cos 60 times sine 60 on the top minus sine 20, and that equals 392. Okay. After we've done this, we can find a value for this. So I'm not going to continue on here for you. You can do this yourself. So this here will come to a value, and then you can find T1. After you've found T1, you can go up here and find T2. That's a T2 there. Once you've just shoved it into this formula here. So that's how you find T1 and T2 in 4A. Looking at 4B, 4B is here. I'll get it up a bit more. There we go. Right here. This time we know the tensional force over here. We know these angles, but we're trying to find this tension here and that mass there. This is T2. It doesn't matter really because we're not going to use any other T's, and that is M. So let's go and do those forces. So this is 4B. Okay. So resolving our forces. So, well, firstly, just do the force diagram. Let's not resolve as we go. It's bad practice. This is mg down here. Now, we've added the g. We'll go back. Once we find this value here, we will actually work it out and go back to m. But I'll show you what I'm going to do in a few more moments with that. So that's T. I don't call it T2 or anything like that because there's only one other T. And this is 274. Right. And the last things I want to put in are the angles. This is 45 up here, and this is 40 here. Okay. Now, it's going to be easier if we just use a single letter for this. So I'm going to remove mg here, and I'm going to replace it with W for weight, because we're going to go back later and have weight equaling mg. I'll just find W. It's just going to be easier to draw these, to write them in the equations rather than having mg all over the place. Okay, I'm just going to tidy up this here, get it around 274. The reason why I just want to make it smaller is because I'm about to resolve. Okay, if this is just resolving this force here, okay, this would be 274 cos 45, and this would be 274 sine 45. Okay, I really didn't need to make that any smaller, really. I'm just going to go this way for this one, only using the bottom one, only for a reason that it's away from this over here, and I don't want to get it all cluttered and whatever. Now, this 40 by alternate angles makes that 40 there. So it's up to you. You don't have to. You could have resolved it this direction up here and just use that 40. It still is exactly the same. This would be t cos 40, and this would be t sine 40. Right, we've resolved all of our forces now. Once again, let's have a look at what forces are in balance. The vertical forces, that one there and that one there, must balance with this one going down here. So what do we've got? We've got t sine 40 plus 274 cos 45 must equal the W force. And the other one is this horizontal force here must equal that horizontal force there because they're in balance. That means 274 sine 45 equals t cos 40. Okay. And we are in luck because this is actually a single value. That means that we can work out t straight away. T would equal 274 sine 45 on cos 40. Once I've got that, I have got a value for t, and it will go into this equation. And that would give us W. Okay, once we've found W, we remember we don't want to find W, we want to find the mass. We want to find M. Okay, and W would equal mg. So M would equal whatever value you got for W divided by 9.8. Okay, I hope this helps. I hope you were successful at this entire worksheet. Thank you.